How can something smaller than your suitcase power a car for hundreds of kilometers without a single drop of fuel? So imagine holding in your hands a device smaller than your suitcase, yet capable of propelling a 2-ton car for hundreds of kilometers without a single drop of gasoline. This isn't the stuff of science fiction. It's the reality behind the electric vehicle battery, one of the most remarkable achievements in modern engineering. But how exactly does this small package harness such monumental power? The answer lies in a hidden world of materials, machinery, and meticulous craftsmanship. A world where raw elements are transformed into the beating heart of tomorrow's transportation. The journey begins far from the gleaming assembly lines of high-tech factories. It starts deep beneath the surface of the Earth, where miners extract lithium, cobalt, and nickel from ancient rock formations. These rare metals, crucial to the battery's performance, are purified through complex chemical processes, emerging as ultrafine powders. Though these powders may appear unremarkable, they hold the potential to store and unleash enormous amounts of energy, a feat that will soon be realized through the magic of manufacturing. Once purified, the powders embark on a journey to ultra-clean, climate-controlled facilities. Here, the air is filtered, every speck of dust is banished, and the standards of cleanliness rival those of semiconductor plants. In these pristine environments, human expertise meets robotic precision. The powders are carefully blended with binders and solvents to form a thick, viscous slurry, a substance that looks very much like black printer ink. This slurry is evenly spread onto whisper-thin metal foils, often made of copper or aluminum, creating a uniform layer that will become the battery's electrodes. The coated foils are then passed through massive ovens, where they are dried and cured to perfection. Any imperfection at this stage could mean disaster down the line. A tiny bubble or crack can compromise both performance and safety. Once baked to exacting standards, the foils are cut into long, narrow strips, each one destined to play a critical role in the battery's anatomy. Now comes a step that borders on the magical. The strips are tightly wound, layer upon layer, forming a spiral that resembles a giant metallic sushi roll. This roll, known as the cell core, is the fundamental building block of the battery. Several of these cells are grouped together, precisely aligned, and connected to form modules. The modules are then encased in a shell of high-strength material, often tougher than the alloys used in aircraft. This enclosure not only shields the battery from physical damage, but also helps manage heat, a vital concern, as even a slight misstep in temperature can trigger catastrophic failure. But before any battery is entrusted with the responsibility of powering a vehicle, it must endure a grueling series of tests. Each unit is subjected to punishing extremes: intense heat, frigid cold, violent shocks, and even simulated collisions. Engineers monitor for the slightest hint of weakness or defect. Only those batteries that survive this ordeal, maintaining flawless performance, are permitted to leave the factory and enter the world. From the harsh environment of underground mines to the spotless corridors of automated cleanrooms, the making of an EV battery is a symphony of science, engineering, and innovation. Every stage demands absolute precision, relentless attention to detail, and a commitment to safety that borders on obsession. The result? A compact, silent powerhouse that makes possible the quiet revolution of electric mobility. So, the next time you see an electric vehicle gliding silently down the road, remember, beneath its sleek exterior lies a marvel of modern manufacturing, a testament to human ingenuity and the quest for a cleaner, more sustainable future.